Hello everyone. So hopefully you've tuned in to see how to draw the graphs of y equals secx, y equals cotx and y equals cosecx. Okay. I'm just going to move away in case you want to screenshot that. Okay. So when you first look at these, you might be like, what? How did that happen? How on earth are you supposed to get this? Well, that's the whole point of the video, isn't it? So I can show you how to do it. So I'm going to take you back to this one. I'll do sine first. Okay. So y equals sine x, the graph looks like this. All right, I've just told you what the graph looks like. It's this. Right. Just bear in mind that cosec x means 1 over sine x. That's important. So you're sketching the reciprocal of this function here. The reciprocal of this y equals 1 over sine x. So critical points are here. So where it crosses the x-axis. Okay, so 0, pi, 2 pi. So you've got sine of 0 equals 0. You've got sine of pi equals 0. And you've got sine 2 pi equals 0. Right? That's why it crosses the x-axis. So when you do the reciprocal, you've got 1 over 0, which is undefined. It tends towards infinity. Okay? And that's why you've got asymptotes. You've got an asymptote here on the y-axis. You've got another asymptote here, where x equals pi. And you've got another asymptote here. And that will be the same on this side as well. You have an asymptote. So basically, every multiple of pi, you'll have an asymptote. So that's kind of explained to you why the graph looks like this sort of interesting shape there. So that's that part. Okay. Right. Secondly, let's look at the maximum minimum values. So the maximum value on the sine graph is this. So sine pi over 2 is equal to 1. Now, when you've got a reciprocal graph, the maximum point becomes a minimum point. Okay, the maximum point becomes a minimum point. The reciprocal of this, 1 over sine pi over 2, is still 1. Okay, so that maximum point becomes a minimum point, which is here. Right? Why is that the case? Because it's reciprocal. Okay, so if I'm saying the largest value of sine x is something, okay, when I do the reciprocal, that will become 1 over sine x, 1 over the largest value, the smallest value. Okay? You just got to remember the largest values become the smallest values, the maximum points become the minimum points. So when you know this is a minimum point, and you've got an asymptote either side, there's only one thing you can do. It's this shape here, and then that is it. This point here, that's a minimum point. Okay, so you've got a minimum point when x is 3 pi over 2, and that's negative 1. The reciprocal of negative 1 is also negative 1, but that minimum point now becomes a maximum point. So here, that's a maximum point. Same again, when you know it's a maximum point here, there's an asymptote either side, there's only one thing the graph can do, that is curve towards the asymptote. Okay? It's periodic in the same way, it repeats every 2 pi radians, so this graph gets repeated indefinitely that way, and this way as well. And that's it, that's the graph. Before I move on, let me just emphasise what I mean by maximum point and minimum point. We tend to say that generally, but we're talking about a local maximum. So basically within this vicinity, that's a local maximum point, because obviously it's not the maximum point on the whole graph, because those points are higher than these. So we talk about a local maximum and a local minimum. Sometimes stationary point is better, but a stationary point could be a maximum or minimum, couldn't it? Which is why I tend to say maximum or minimum. So that's that one. And then the cosine graph, when you do the reciprocal of that, exactly the same thing. So when you realise these ones have got asymptotes, the first thing you look for is where the graph crosses the x-axis. It crosses it here, here, here. So cosine pi over 2, cosine 3 pi over 2, and their negative equivalents all give you 0. So the reciprocal of that, okay, notice what I'm doing with my hands, the reciprocal, it's almost like turning a fraction upside down. You have 1 over 0, which is undefined. You get asymptotes. So the asymptotes appear at pi over 2, so just put this in here, there, and 3 pi over 2. And the negative equivalent, so negative pi over 2, negative 3 pi over 2. And the next thing is to consider about the maximum minimum points. They become the reverse. So that maximum point becomes a minimum point. So rather than 0, 1 being a maximum, 0, 1 would be a minimum. And then the graph looks like that. Pi negative 1 minimum, that becomes pi negative 1 maximum. And once you've got this part of the graph drawn in, the rest of it is easy because it's repeated. Okay? I'll go over it too quickly. Remember, you can pause or rewind the video, replay it, which is great. Okay? The tan graph, okay? Now they've got asymptotes already, so we'll get to that in a minute. Okay, so let's just look to see where it crosses the x-axis first. So every multiple of pi, just like the sine graph, of course. Okay, there's a reason why I've said of course, which I'll come to in a minute. So tan 0, tan pi, tan 2 pi, and so on is 0. So the reciprocal of those, okay, that will be 1 over tan x, 1 over 0, undefined. So asymptotes at negative pi, at negative 2 pi, at the y-axis positive pi, and this graph repeats every pi radians, just the same as the tan graph repeats every pi radians. What about these asymptotes? Okay, so let's think about tan of pi over 2. That's undefined, isn't it? Okay, think of it loosely speaking as being infinity. Yeah, tan pi over 2 is infinity. Then think of 1 over infinity, tends towards 0. But that's not precise, is it? Okay, so that's why I've written it like this, to try and explain to you precisely what is going on. So when you've got tan pi over 2, you've essentially got sine pi over 2 over cosine pi over 2. Remember, tan is the same as sine over cosine. Sine pi over 2, okay, that's equal to 1. Cosine pi over 2 is equal to 0. 1 divided by 0, hence why it's undefined. But you take the reciprocal of that, okay? If you take the reciprocal, if you do cosine pi over 2 over sine pi over 2, then what's happening is you're going to get 0, cosine pi over 2, over sine pi over 2, 1. 0 divided by 1, which is 0. So when you've got x equals pi over 2, the graph crosses the x-axis there. And the same thing for when you've got cosine 3 pi over 2. Your cosine 3 pi over 2 is 0, sine 3 pi over 2 is negative 1, 0 divided by negative 1 is 0. And consequently, the graph is going to cross the x-axis at all these points here, every multiple of pi over 2. And then because of the asymptotes, it's got to either do this or this. Now, how do you know which way round it is? Well, the tan graph between 0 and pi over 2 is always positive. Whoops, I strayed a little bit towards the asymptote there, which is not good. So the tan graph, there we go. It's always positive. So the reciprocal of positive number will remain a positive number. So between 0 and pi over 2, it's positive. So that's why it's got to be doing this here, and not that. It can't be negative. So when it's doing this, there's no stationary points. Well, correct that. There's no maximum or minimum points. Okay, and so it just continues to do this. Okay. The reason I corrected myself is because I don't want to get into points of inflection. We don't need to talk about that. Okay. And that is it. Okay. And this is my starting screen. That shows you why the graphs do look like that. Okay. Right. I'm hoping you found that interesting. I hope you got something out of it. Okay. See you again soon.